content today, which is on perceptrons. So in the past lecture on Tuesday, we covered the naive Bayes algorithm, which is part of a general class of algorithms where you model the data based on, you create a probability distribution over your data, and then you perform classification by doing probabilistic inference. And today we're going to look at a class of algorithms that do error-driven classification. And what that means is that they look at the errors and they optimize the classification performance by minimizing the errors that occur on the training set. So in the naive Bayes algorithm, we saw it does pretty well when you're working just with text. However, it'll still make some errors. And some examples of the errors that it might make is that if it gets these two emails, if you just look at the text on these emails and nothing else, they look pretty similar. So the first one says, "Dear GlobalScape customer, GlobalScape has partnered with Scansoft to offer you the latest version of the OmniPage Pro." Versus the second email says, "To receive your $30 promotional certificate, click through to amazon.com/apparel." However, just by looking at the text, it's hard to tell whether these are spam or not. You want to know whether it's an unsolicited email. So there's other features that you might want to include, like have you emailed the sender before, or did that email go out to 100 million other people? And that naive Bayes algorithm won't do well in this case because the features aren't homogeneous. They're very non-independent in different ways, and they might be on different scales. And therefore, the conditional independency assumptions that are made in naive Bayes algorithm are going to be violated in different ways, and we want a better algorithm, and that's where error-driven models come in. These error-driven models are also going to be based on some features that you define, but it doesn't make any assumptions about the features that you define, and it simply just tries to optimize its classification accuracy based on the data set that it sees. And then later on in lecture, if we have time today, we'll also see how we can apply these algorithms to other problems, not just to classification, such as web search and decision problems.